We're going to check over your study guide. So you need to follow along and check your work as we go. So for the first questions on the first page, you were to use this word bank. Number 1, an object is in motion when its distance from another object is changing. Number 2, a place or object used for comparison to determine if something is in motion is a reference point. The basic SI unit of length is the meter. The distance an object travels per unit time is its speed. When you know both the speed and the direction of an object's motion, you know the velocity of the object. The steepness or slant of a line on a graph is called its slope. Remember, the steeper the slope, the greater the motion, be it speed or acceleration. The rate at which velocity changes is acceleration. A direct relationship is when a graphed line rises the same amount each second. It's a straight diagonal line. Number 1, the formula for speed is equal to distance divided by time. If the speed of an object does not change, the object is traveling at a constant speed. Independent variable is plotted on the x-axis, which is your horizontal axis, and your dependent variable is plotted on the y-axis, which is your vertical axis. The faster the motion, the steeper the slope. A distance time graph with a constant slope represents motion at a constant speed. A horizontal line on a distance time graph represents an object that is at rest. If we were to use the speed formula and we were trying to solve for distance, distance is going to equal speed times time. Remember your triangle. Speed is distance over time. So cover up what you're trying to solve for. In this case, they're side by side, so you would multiply your speed times your time to get your answer in as a distance. Acceleration refers to increasing speed, decreasing speed, or changing direction. Make sure you count up how many you got wrong on the first page and make a note somewhere on the first page. When velocity is measured in meters per second and time is measured in seconds, the unit for acceleration will be meters per second or meters per second squared. The type of graph that is used to show changes over time is a line graph. The type of graph that is used to compare quantities or categories of data is a bar graph. The type of graph that shows what percentage of a whole a particular category makes up is a pie graph. What 3 kinds of change in motion are called acceleration, speeding up, slowing down, or turning, which is changing direction. The formula we use to calculate acceleration is final velocity minus initial velocity divided by time. All right, your sets of word problems, you need to follow the directions that you have been following in class, which means you need to circle your numbers in your problem, underline your unit. So in this case, we have the question, what is the speed of a jet plane that travels 528 meters in 4 seconds? Then you box in what you're trying to solve for, which in this case is speed. We put a question mark next to the variable we're trying to solve for. We list all of our variables with units. So we've got the distance is 528 meters and the time is 4 seconds. Next thing we do is write our formula. Speed is distance divided by time. Now we substitute. Our distance is 528 meters over 4 seconds. You do the math on that, your answer will be 132, make sure you include your units, meters per second. And then check, is this unit a unit for speed? Yes, because speed is distance divided by time. And then circle your answer. Number 2, how long will your trip take in hours if you travel 360 kilometers at an average speed of 80 kilometers per hour? We're solving for distance. We're solving for time. Our speed is given to us of 80 kilometers per hour. Our distance is 360 kilometers. We're solving for time. Time, cover up what you're trying to solve for, is distance divided by speed. Substitute distance with your unit and your speed value with its unit. As you can see, your kilometers cancel out and you're left with hours, which is a unit for time, 4.5 hours. Number 3, how far in meters will you travel in 3 minutes running at a rate of 6 meters per second? Our rate of 6 meters per second is our speed. Our time is 3 minutes. And our distance, we don't know. So distance is speed times time. Our speed is 6 meters per second. Our time is in minutes. Well, we need to change minutes into seconds. So our minutes are going to cancel out, our seconds are going to cancel out, and we're going to be left with meters as our unit for distance. So 6 times 3 times 60 is 1,080 meters. The question asks for it in meters, so we're going to keep it in meters. Number 4. A trip to Mount Abu takes 10 hours. The distance is 810 kilometers. We're calculating the average speed. Distance is 810 kilometers. Our time is 10 hours. Speed is equal to distance divided by time. Total distance is 810 kilometers. Our total time was 10 hours. Average speed is total distance divided by total time. So we're going to get 81 kilometers per hour. How many seconds will it take for a satellite to travel 480 kilometers at a rate of 120 meters per second? And we're solving for time. Our speed's 120 meters per second. Our distance is 480 kilometers, and we're trying to solve for time. Time is distance divided by speed. Let's write out our formula. Now let's substitute. 480 kilometers is our distance. Our speed, 120 meters per second. Now, we need our units to be the same here for distance. So 480 kilometers equals how many meters? Remember your conversions. Kilo, hecto, deca, base unit, deci, centi, milli. Well, we're going from kilo to base unit, meters. We have to move our decimal 1, 2, 3 to the right. Our decimals here, 1, 2, 3 to the right, add circles. Okay, so that is our answer in meters, 480,000 meters per 120 meters per second. Our meters are going to cancel out. We take 480,000 divided by 120. You're going to get 4,000 seconds. It's asking seconds, so we have to keep it in seconds. What is the speed of a walking person in meters per second if the person travels 1,000 meters in 20 minutes? So we need to change our minutes to seconds. So we know 20 minutes, we set up a ratio. We know in 1 minute there are 60 seconds. We have minutes on the top and the bottom. They cancel out. If we multiply 60 times 20, we're going to use 1,200 seconds for our time. And then our distance is 1,000 meters. We're trying to find speed. Speed is equal to distance over time. 1,000 meters divided by 1,200 seconds is 0.8 meters per second. All right, number 7. A ball rolls down a ramp for 15 seconds. If the initial velocity of the ball, is 0.8 meters per second. Let's put that right there so we know it's initial. And the final was 7 meters per second. What is the acceleration of the ball? Final velocity is 7 meters per second, and it takes 15 seconds for it to roll down the ramp. So we need to write our formula for acceleration, which is final velocity minus initial velocity over time. Now we substitute. Final velocity is 7 meters per second minus initial velocity of 0.8 meters per second divided by 15 seconds. And we will get 4.4 meters per second, or 0.4 meters per second squared. Okay, if we haven't had enough already, we got some more questions on acceleration to really hit home how to do problems like this. Number 8. A meteoroid changed velocity from 1 kilometer per second to 1.8 kilometers per second in 0.03 seconds. What is the acceleration of the meteoroid? All right, so it's sped up because it went from 1 to 1.8 kilometers per second. So this is your final velocity, 1.8 kilometers per second. Initial velocity is 1 kilometer per second, and it took 0.03 seconds to speed up. So write out your formula first, Then substitute your values and your units. 1.8 kilometers per second minus 1 kilometer per second divided by 0.03 seconds. And we will round to the tenths place. So you should have 26.7 kilometers per second squared. And we are rounding to the tenths place because the least accurate measurement in this problem is the top two numbers, which are to the tenths place. A car going 50 meters per second accelerates to pass a truck. 5 seconds later, the car is going 80 meters per second. Calculate the acceleration of the car. It's sped up, so the final velocity is 80 meters per second. Initial velocity is 50 meters per second. And it took 5 seconds for the car to accelerate. Write out your formula. Substitute. Last step, solve. Well, you can either write it meters per second or meters per second squared for the unit. Number 10. A ball is rolled at a velocity of 12 meters per second. After 36 seconds, it comes to a stop. What is the acceleration of the ball? So because it comes to a stop, that is its final velocity, which is 0 meters per second. Its initial velocity is 12 meters per second, and it took 36 seconds. So because the ball is coming to a stop, we know that it's slowing down, which means we should get a negative acceleration. So final velocity, 0 meters per second, minus 12 meters per second, divided by 36 seconds, which is negative. And we'll just keep it to the tenths place, so 0.3. And then your unit for velocity is meters per second and time is second, so it's meters per second, or meters per second squared. So here, all you're adding is either V for velocity, T for time, D for distance, S for speed, or A for acceleration. So kilometers is a unit for distance. Seconds is a unit for time. Kilometers per hour north is a unit for velocity, speed in a given direction. Meters per second is a unit for speed. Kilometers per hour per second is a unit for acceleration, as is meters per second squared. You're describing what is happening to each lettered line in each graph, and then you're calculating the average speed for graph 1 and accelerations for graph 2. The only thing different between these two graphs is the vertical axis. So here we're looking at a speed graph because speed is distance divided by time, and that's what the variables are on the y and x axis. And in this case, we're looking at the change in speed as time goes by, which is an acceleration graph, because acceleration is the change in speed over time, or change in velocity over time. So from this point to this point here, this line is a straight diagonal line, which represents constant speed. And to calculate the average speed, we take the total distance, which is 120 meters, divided by the total time, which is 30 seconds. Letter B, because it's a flat horizontal line on a distance time graph, that means the object is not moving. No speed. Letter C, this segment, the object is again traveling at a constant speed because we have a straight diagonal line on a distance time graph. .50 seconds. It starts 50 seconds and the object stops at 70. So remember, to get average speed is total distance. So here it's at 180 meters and here it's at 120 meters. So 180 minus 120. And the time is 70 seconds minus 50 seconds. It's 60 meters over 20 seconds, 3 meters per second. And you can see segment A is a steeper line than segment C. So it makes sense that the speed is different here and it's less because it's not as steep as a line as segment A. And now we're calculating the speed from this point to point of origin, which is the time difference here is 100 minus 70 seconds, and the distance difference is 180 and 0 meters. So this is also constant speed, going back to point of origin, traveling to point of origin. So total distance is 180 meters, and the total time it took for that object to go from 180 meters to 0 is the difference in 100 seconds minus 70 seconds. 6 meters per second. And you can see this line is much steeper. All right, last thing. We are looking at acceleration graph. So as time goes by, do you see how the acceleration is constant? It's constantly increasing its speed. So it's constant acceleration instead of constant speed. And we figure out the acceleration again by comparing the speed here, which is 120, because acceleration is final velocity minus initial velocity over time. So 120 meters per second minus 0 meters per second. And the change in time at 30 seconds minus 0 seconds. Acceleration will be 4 meters per second squared. F, we know as this time goes by that the object's speed is not changing. It's still 120 meters per second. So when we calculate the acceleration with a constant speed, we have no acceleration. And we can prove that with the formula. Final acceleration is 120 meters per second. Initial acceleration is 120 meters per second. And the time it took to travel from here to here is 20 seconds. So 120 minus 120 is 0. So there is no acceleration, 0 meters per second per second. All right, for G, this object is traveling at a constant acceleration because as time goes by, its speed is increasing at the same rate. So we have, instead of constant speed here, we have constant acceleration. Final velocity is 180 meters per second. Initial velocity is right here at 120 meters per second. And the time it took it to go from 120 to 180 is the difference between 70 seconds and 50 seconds. Which will be 3 meters per second squared. Okay, last one. The object is going from 180 meters per second down to 0 meters per second. So it's constant deceleration because the object is slowing down at a constant rate. So our number should be a negative number. Final velocity is 0 meters per second. Initial velocity is 180 meters per second. And the time it took the object to go from 180 meters per second to 0 is the difference between 100 seconds and 70 seconds. And this is a negative 6 meters per second squared. All right. Make sure you review this, and if you have questions, come see me.